In this Etabs tutorial, we will create, analyze, and design a 6-story steel building, and then export the data out in a CIS2 step formatted file, where it can be imported by other applications. Our 6-story building model will be steel framed, approximately 72 feet square in plan. It will have composite floor beams. It will be analyzed for dead, live, and wind loads. Members will be selected by the program based on least weight using the AISC LRFD 99 code. And finally, the data will be exported out in the CIS2 format. We will create the model from one of Etabs' template options. Before we start, we will set the default units to kip feet. Using the new model command, we set the number of stories to 6. And select the steel deck option. Under the structural system properties, notice the items assigned to the columns and beams. These are not specific member sizes, but rather are lists of sections from which the program may choose. To review these auto-select lists, go to the Define Frames command. Highlight a list, in this case the list for the composite beams, and ask to see the properties. Here's the list of all of the member sizes from which the program can select. Next, we will modify the plan shape of our building. One of the powerful features in Etabs is the Plan View Story Assignment Control option. Here you can control the number of stories that you work with in a plan view. We will set this control to all stories. Select the floor deck and hit Delete. This deletes the deck at all levels. Next, we select the beams and columns to be removed and hit Delete. Now that the plan shape has been altered, we need to draw back in the deck, again with all stories selected. Make sure that the local axis is set to 90 degrees so that the deck spans the correct direction. The last step in defining our deck is to expand the edge 1 foot around the perimeter. We now turn on the fill option to give us a better idea of what the building looks like. Again, with all stories selected, we will assign to the floor objects a live load of 150 pounds per square foot in the gravity direction. We are also going to assume that the floor diaphragm will act as rigid. Next, we will add our wind load case. We will let the program automatically generate the wind loads based on the ASCE 7-02 code. The loads will be based on the diaphragm exposure and will have a direction angle of 0, which results in a load in the x direction. We are now ready to run the analysis. To start the analysis, click on the Run Analysis button. We will save the file as Etabs CIS2. Upon completion of the analysis, the deformed shape for the dead load case is displayed on the 3D view. Going to the display menu, we can display the deformed shape for the wind load on the plan view. Now let's go to Design. The first thing we need to do for design is to set the design code preference, and here for both the steel frame design and for composite beam design, we will use the AISC LRFD 99 code. Now we can start the design of the composite beams by simply clicking on the Start Design using Similarity command. Upon completion of the design, the color-coded stress check ratios and member selection are displayed. A right-click on any member brings up an information form where detailed information may be obtained about the member design, including stress ratios, stud layout, and deflections. Next, we will design the steel frame portion of the building. Upon completion of the design, the program gives a warning specifying that the sections picked by the program in design do not match those used in the initial analysis, thereby indicating that another analysis should be run with the updated sections. Switching to an elevation view shows us the columns and beams selected. Again, a right-click on any frame member brings up an information form where the stress ratio and governing load combination are displayed. Note that this form shows the difference between the analysis and design sections. A detailed calculation sheet may be viewed by clicking on the Details button. We are now ready to export the model in a CIS2 file. Creating a CIS2 step file is simple in Etabs. Simply use the Export command, which displays the CIS2 step form. Here we can specify the various standards to use, such as the AISC EDI standard nomenclature. The user can also choose to send out loads, as well as analysis and design results in the file. The model may now be imported into any other application supporting the CIS2 step file format.